Internet working, concepts, architecture, and protocols. Introduction. Previous chapters describe the basic networking, including the hardware components used in LAN and WAN networks, as well as general concepts such as addressing and routing. This chapter begins an examination of a fundamentally new idea in computer communication, an internetworking technology that can be used to connect multiple physical networks into a large uniform communication system. The chapter discusses the motivation for internetworking, introduces the hardware components used, describes the architecture in which those components are connected, and discusses the significance of the concept. The remaining chapters in this section expand the Internet working concept and provide additional details about the technology. They examine the individual protocols and explain how each uses techniques from Chapter 12 to achieve reliable, error-free communication. The next section describes applications that use Internet working technology. The motivation for Internet working. Each network technology is designed to fit a specific set of constraints. For example, LAN technologies are designed to provide high-speed communication across short distances, while WAN technologies are designed to provide communication across large areas. And consequently, no single networking technology is best for all needs. A large organization with diverse networking requirements needs multiple physical networks. More important, if the organization chooses the type network that is best for each task, the organization will have multiple types of networks. For example, a LAN technology like Ethernet might be the best solution for connecting computers in an office, but a frame relay service might be used to interconnect computers in one city with computers in another. The concept of universal service. The chief problem with the multiple networks should be obvious. A computer attached to a given network can only communicate with other computers attached to the same network. The problem became evident in the 1970s as large organizations began to acquire multiple networks. Each network in the organization formed an island. In many early installations, each computer attached to a single network and employees had to choose a computer appropriate for each task. That is, an employee was given access to multiple screens and keyboards, and the employee was forced to move from one computer to another to send a message across the appropriate network. Users are neither satisfied nor productive when they must use a separate computer for each network. Consequently, most modern computer communication systems allow communication between any two computers, analogous to the way a telephone system provides communication between any two telephones. Known as universal service, the concept is a fundamental part of networking. And with the universal service, a user on any computer in any part of an organization can send messages or data to any other user. And furthermore, a user does not need to change computer systems when changing tasks. All information is available to all computers. As a result, users are more productive. And to summarize is that a communication system that supplies universal service allows arbitrary pairs of computers to communicate. Universal service is desirable because it increases individual productivity. Universal service in a heterogeneous world. Does universal service mean an organization needs to adopt a single network technology? Or is it possible to have universal service across multiple networks that use multiple technologies? In Chapter 9, we learned that electrical incompatibilities make it impossible to form a large network merely by interconnecting the wires from two networks. Extension techniques such as bridging cannot be used with heterogeneous network technologies because different network technologies use incompatible packet formats and addressing schemes. Thus, a frame created for one network technology cannot be transmitted on a network that uses a different technology, and the point can be summarized. Although universal service is highly desirable, incompatibilities among network hardware and physical addressing prevent an organization from building a bridged network that includes arbitrary technologies.